In this video, I will be going over showing convergence and divergence of series by definition. What is the definition? Well, you need to have some sort of series that's a summation of general terms an, and you can take the partial sum, the nth partial sum, which is just going to be a0 plus a1 plus a2 all the way up to an, and then you take the limit of that partial sum as n goes to infinity, and you see if you get a finite sum, basically if the limit exists. If the limit exists, you get convergence at whatever the summation is, and if it doesn't, you get divergence. You usually use the definition to show convergence and divergence with telescoping sums, and telescoping sums are pretty rare to come across, and as a result I don't have many examples in this video. So you rarely use the definition to prove convergence or divergence, but it is very useful to show the actual sum that a series converges to. So let's take a look at our first example, which is the summation of 1 over square root n minus 1 over square root n plus 1. So we're going to take the limit of the partial sum, and the partial sum is just going to be a0 plus a1 plus a2, etc. And a0 in this case, it's the first item of the sum, so it's going to be 1 over square root 4 minus 1 over square root 5. And then we're going to keep going. We're going to add the a1 term, which is going to be 1 over square root 5 minus 1 over square root 6. And you want to keep going until you see some cancellation happening, and then you can go from the other side where you have n minus 1 minus 1 over square root n, and now you can see the cancellation, so you can take away the subtraction and the addition parts, and then you're left with the limit of n goes to infinity of 1 over square root 4, and the other part is just going to give you a 1 over infinity, so that's 0, so you're left with 1 over square root 4. Now let's look at the example of the summation of 1 over 3k minus 1 over 3k plus 1. So again, we look at the limit n goes to infinity of the partial sum. The first term is going to be 1 over 3 to the 0 minus 1 over 3 to the 1. The second term is going to be 1 over 3 to the 1 minus 1 over 3 to the 2. Immediately we can see cancellation with the 1 over 3 to the 1s. So let's work towards the end with k minus 1 minus 1 over 3k, and then finish it out with 1 over 3k minus 1 over 3k plus 1. You can cancel out the addition and subtraction, and you're just left with 1 over 3 to the 0, so that's just 1 over 1 minus 1 over 3k plus 1, and if you let k go to infinity, you're going to get 0, so you're just going to be left with 1. Now let's look at the example of ln of n over n plus 1. So for this one we can do the log rule, where we can split up the n over n plus 1 into ln n minus ln n plus 1, and then we can write the limit n goes to infinity of the partial sum, not this one, the partial sum Sn, and that's going to be, take the first term, it starts at 2, so it's going to be ln 2 minus ln 3 plus ln 3 minus ln 4, and we see the cancellation. So again, we start from n minus 1 minus ln n, and then end with ln n minus ln n plus 1, and then we do the cancellation and see what's left over. We end up getting ln 2 minus ln n plus 1, and in this case that is going to be infinity, so we're subtracting infinity. That's going to be negative infinity, and that gives us divergence. If you wanted to show whether this one converged or diverged, you could do an easy comparison test and just minimize the denominator by taking out the 3n. But if you wanted to find the actual sum, you would have to use by definition. So what we'll do is we'll have to do some voodoo magic where we add n and then subtract n on the numerator, and that allows us to get some cancellation going on. So the 3 plus n, if we split it up, we can cancel that out with the n plus 3, and then the n we can cancel out, so we end up getting a telescoping 1 over n minus 1 over n plus 3, and then we can get the limit of the partial sums of that. So the first term, it starts at 2. So if you plug that in, it's going to be 1 over 2 minus 1 over 5 as the first term. And then the second term is going to be 1 over 3. That's going to be the limit as n goes to infinity. You have to remember that. So it's going to be 1 over 3 minus 1 over 6. And I guess we can just continue to go on until we see cancellation. Right now we're not getting any cancellation. But now we're getting cancellation. We're getting 1 over 5 minus 1 over 8. So that 1 over 5 is going to cancel with the 1 over 5 in the first term. And for this one, we're going to start it a little bit earlier because there's not as much cancellation on this one. So we're going to start at 1 over n minus 3. And see what terms cancel out here. So we're gonna keep on going until we get to n, and then it honestly doesn't matter too much because all these terms at the end, they're just gonna give us 0 because it's 1 over infinity. But we can proceed to cancel out all the terms that will vanish as a result of adding and subtracting themselves, and then we can get the limit as n goes to infinity of whatever's left. So in this case we are left with 1 over 2 plus 1 over 3 plus 1 over 4 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3, and then the last 3 terms are just 0, so our series is going to converge to the first 3 terms summed up.